an all-encompassing question. It says, a ball is tossed upward with a velocity of 102.4 feet per second from a height of 15 feet. The height of the ball after t seconds after it's tossed is given by, and there is your formula. And then you see 102. Negative 16 is always due to acceleration due to gravity. So you see that in every problem involving balls and pennies and anything else that's going down, right? And then 102.4 is going to be your coefficient of t. That's how fast it's traveling in the beginning. When we dropped the penny, how fast was it traveling in the beginning? It wasn't traveling at all because we just dropped it, so we didn't throw it with any kind of force. And then there's your 15 feet. So if I think of the picture, then of course up and down. So all these guys kind of look the same. This is ground. This is 0. So essentially the wall becomes the x-axis. And this right here is 15. So that's how high off the ground it starts. So if I were to put an x and y axis, kind of overlay that, that's what this would be. There's your y-axis right there. And then ground, that's your x-axis. So everything is happening in the first quadrant. Well, that should, because x and y is going to have to be positive. Now, what are the units? Well, t is time. And time is in seconds. And f of t is height, and looks like it's in feet. So height in feet. That kind of helps me to know whether I'm looking for x or whether I'm looking for y. And that's true of the first one. It says how high. How high is height, so I want to know what y is. Is the ball after 1 second when t equal 1. So that tells me I'm going to put in t, put in x, and get out y. So this then becomes f of 1, which is negative 16 times 1 squared, plus 102.4 times 1, plus 15. And this comes out to be 101.4 feet. So that thing is traveling pretty fast. So in 1 second, it goes from 15 to 101 feet. But figure, it's traveling at 102 feet per second. When will the ball be 20 feet above the ground? 20 feet above the ground. Now, if we go back to our picture, there it is. Notice 15 feet where it starts. Is 20 bigger than 15? Yeah. So we're at 20. If this is 20 feet, how many answers will I have? 2. One going up, one going down. If it were smaller than 15, then I would only have 1. And that's coming down because it started higher than 15 feet to begin with. So that's my picture. So that means I am looking for the y value to be 20, or negative 16 t squared plus 102.4t plus 15 equals 20, or negative 16 t squared plus 102.4t minus 5 to be equal to 0. And we know without a shadow of a doubt this sucker is not going to factor. So we're stuck with the quadratic formula. So t is going to be equal to minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative 102.4 plus or minus the square root of, these are not fun problems, 102.4 squared minus 4 times a times c ups 4 times a times c. I can understand if I use my other calculator. So it's 10165.76.
Does that matter if we put 8.8?
You could do that too. All over negative 32, which is minus 102.4 plus or minus, now I got to take the square root of this sucker, second square root of 10165.766, which is 100.8, all over negative 32. Or t is, everybody ready to jump off the building yet? Negative, I know I am, 102.4 plus 100.8 over negative 32, or t is negative 102.4 minus 100.8 all over negative 32. Or t is negative 102.4 plus 100.8 divided by negative 32. I came up with 0.05. And then we do the same thing only this time it is minus, and that's going to be divided by negative 32 and 6.35. The one thing that I have to concern myself from a test standpoint is the problems don't get too long, because they can easily get too long because of the numbers involved.